In our next set of examples, we are going to learn how to calculate arc length. Basically, for arc length, we're just going to be finding a certain distance around the circle, but not the whole circle like circumference calculates. So arc length is just going to be a portion around the circle. So similar to like if this were a sliced pizza, we'd be figuring out how long the crust is. So in a circle, the ratio of the length of the arc to the circumference is equal to the ratio of the measure of the arc to 360. So we're setting up these ratios, these fractions. This arc length of AB divided by 2 pi r, so divided by that circumference, is equal to the measurement of that arc divided by 360, or, and this is the formula we're going to use right here, the arc length of AB is equal to the measure of arc AB divided by 360 and then multiplied by 2 pi r, so multiplied by that circumference. That did not do a great job. Here, I'll put a box around it. So this is going to be the formula that we are going to be using to find an arc length. So we'll start off with our first example A. We want to find the arc length of arc AB. So basically we're finding this measurement right here. We're going to follow our formula. So the formula starts with arc length. So I'll write out arc length. And that's going to be equal to the measurement of arc AB. So what we have here is a 60-degree angle inside of that circle, and this angle on the outside of the circle is also going to be 60 degrees. So the central angle of a circle is going to be equal to, so it'll have the same measurement in degrees as this, if it were a slice of pizza, this crust right here. So we're going to take that 60-degree arc length, we're going to divide that by 360, and then we're going to multiply by the circumference, 2 pi, and then the radius. So here's our radius of our circle right here. That's that 8 centimeters. What we can do next is we can use our calculator if we want to reduce the fraction. So we have 60 over 360. Oops, that's not it. So we had the fraction 60 over 360. So you guys can reduce this in your calculator. So that would be 1/6. So 60 over 360 is 1/6. And then for the 2 pi times 8, we can multiply 2 times 8 to make 16. Then what we can do is we can multiply, like if this were 2 fractions, we can put this over 1, numerator times numerator, denominator times denominator. So 1 times 16 pi is 16 pi. Then we put that over 6. And then one more step. Let's reduce. So if you want to put into your calculator 16 divided by 6, that ends up getting us 8/3. So that arc length would be 8 over 3, or 8/3 pi. We can put the pi to the side like that, or we can put the pi in the numerator if we want. So just some equivalent ways to write this. You can write it as 8/3 pi, or 8 pi over 3. Or let's say we wanted to figure out like what actually is that measurement. We can put this in our calculator. 8 divided by 3 pi. So it's about 8.4 centimeters for that arc length. So all equivalent answers, 8/3 pi, 8 pi over 3, or 8.4 centimeters. So that would be how long that length of that arc is. In our next example, example B, we need to find the circumference of circle Z. So what we're looking for is the distance all the way around this circle. We don't know the radius and we don't know the diameter. So that means we're going to have to use this arc length formula to hopefully help us figure out the circumference. So what we do know, 4.19 inches, this is our arc length. This is our arc length XY. We have this center angle of 40 degrees. That center angle of 40 degrees.
Mommy.
Yeah, that's the measure of arc XY.
These two hands are stuck in the baby's outfit.
I got it. So if we substitute that information into our arc length formula, we'll be able to figure out the radius of the circle. And then once we know the radius of the circle, that will help us to find the circumference of the circle. Shan, this is really hard to do. Right, you gotta give me a minute. So let's start off with following our formula, the arc length. So we know the arc length of XY, that was that 4.19 inches. That's going to be equal to the measurement of the arc, which is 40 degrees over 360 degrees. And then we would multiply that by 2 pi and then times the radius. So some things we can do to start us off. The divided by 360, to undo divided by 360, we can multiply by 360. So on both sides, I'm going to multiply by 360. Let's calculate that. 4.19 times 360. That's 1508.4. So 1508.4 equals, and then let's just keep track of what we're doing here. The divided by 360 and the multiply by 360. Those are going to undo each other. So if we're looking at this equation now, we have 40 times 2, so we can multiply those numbers together. 40 times 2 is 80, so give us 80. Pi, and then times that radius. So basically putting together 40 and 2, multiplying them together, and then leaving that pi and that radius. We do want to solve for radius. We can divide by 80 pi. So if we use our calculator for this calculation, that's going to give us the radius of our circle. So we'll take that answer, 1508.4, and we're going to divide by 80 pi. And then this is going to give us a radius of 6. My radius is 6 inches. And now I'm able to find the circumference of the circle. Remember from the other page, circumference is equal to 2 pi r, so 2 times pi times radius. So our circumference would be 2 pi times 6, or 12 pi. And then for our units, we were measuring in inches. So we used that arc length formula to help us get radius, and then the radius can now be substituted into our circumference formula. In our last example here, we need to find the measure of angle RS. So what we're looking for is the measurement of that arc. Like, so if it were like a pizza crust, we'd be looking for the measurement of that pizza crust. So like right here, we're looking for how many degrees around the circle that would be. Remember, that would be equal to however big this angle is inside here, which we also don't know. As far as what part of the formula is that, that would be this right here. So we'd be looking for solving for this part of our formula. As far as what do we have this 15.28 meters. This is going to be our radius. We know how far along the arc we have here. That's our arc length. So we have arc length, RS. That's equal to 44 meters. And then, like I said, we were trying to find the measurement of that arc in degrees. So if we start using our arc length formula, the formula starts with arc length. So that arc length, that's our measurement of 44 meters. And that's going to be equal, I can get rid of the meters, 44 equals the measurement of our angle in degrees, so of our arc in degrees. So we don't know that, so I'm just going to put the measure of arc RS in degrees. I'm trying to find that. We're going to divide by 360, and then we're going to multiply by 2 pi times the radius of 15.28. First thing we can do, because we usually don't like to work with fractions, is we can multiply both sides by 360 to clear the fraction. So we're working on 44 times 360 using our calculators. It's going to give us 15,840. 15,840 is going to be equal to, and then just a heads up, like we were going to divide and multiply, so those 360s are not here anymore. What we can do is multiply together the number 2 and the 15.28. So let's work on that. 2 times 15.28, that's going to give us 30.56. That measurement of arc RS multiplied by that answer that we just got. What was it? I forgot. 30.56. And then we've got the pi still in our equation. We want to solve, so we're going to divide by that 30.56 pi, both sides. And now we're able to get our answer for the measurement of that arc in degrees, because those are going to divide out, leaving us with the measurement of arc RS in degrees. So we'll use that calculator to divide. Making sure I did this right. So let's say we wanted to round this. Let's get this to the nearest whole number. This is about 165 degrees. So that arc measurement is about 165 degrees. So just 3 examples of how we can figure out different parts of our circle using that arc length formula. You guys work on the you try it's, and then I'll make another video explaining those answers.